Hey everyone, it's Dr. O here. So I wanted to make this video about lab number 4 that we are doing this week on the endocrine system. So I wanted to just do this video just to kind of help explain a little bit extra. I think this is the kind of lab that you would benefit the most from having me present there, kind of helping you out. Why do we do this? Why are we making this conclusion? What sorts of things are we looking for? Obviously, since we are doing things virtually right now, I can't do that, but I wanted to do, I think, the next best thing and just give you a little bit of an idea of what you kind of should be your thought process in doing this lab. So what I have here is I have my copy of the lab. So the thing that you'll want to kind of do, and to be clear, the first 11 or so or 12 questions are just basically, can you read the information in the lab and answer questions on it? So that should give you a lot of the background information on the endocrine system that you need to do this lab. And then the last part of it is basically you are told that, if we can go here, yeah, so basically this part of the lab that is titled laboratory procedure, it basically tells you this story here, and I can just kind of briefly sum it up. Basically, you work in a laboratory that studies these hormones, and you injected 6 rats with 6 different hormones as part of a study, but for some reason, the bottles of hormone were not properly labeled. So it says somewhere here at the bottom what your hormone choices are. So you know that the 6 hormones are either ACTH, cortisol, luteinizing hormone, thyroid stimulating hormone, thyrotropin releasing hormone, or testosterone. So you know those are your 6 hormones. You're just not quite sure which rat was injected with which hormone. So what you're going to do here to try to figure out which rat was injected with which hormone is you are given the information on these autopsies from each of the rats. So these rats come in pairs. So you're always going to have an intact rat and a castrated rat. So the castrated rat obviously has had its testicles removed before the injection of the hormone. So the intact rat will have its testicles, so basically you can use those pieces of information to understand, okay, what effect does the testes and the ability to produce its own testosterone have on the injection of the hormone. So this first page that you see right here, it is listed as control. So these 2 rats that you see right here were not injected with any particular hormone. So these numbers that you see right here, the masses of each of those tissues is going to serve as your basis of comparison for every comparison that you do. And then each page after that lists the rats that were injected with a particular hormone. So this is hormone 1, this is hormone 2, and so on and so forth. So what I want to do here is I want to show you how to do these comparisons using the formula that I gave you in the instructions. So I went ahead and wrote down the weights for the control intact rat and the hormone 1 treated intact rat. So that's going to be the first comparison that we do here. So what you're going to do is you are going to compare this number to this number, this number to this number, to see how the injection of whatever hormone was injected is going to affect the masses of these particular tissues. So the equation that you're going to use here in order to determine how much something has changed is going to be this one here. So it is percent change. That is going to equal the initial mass, or excuse me, I have that wrong. That is the final mass minus the initial mass. And then we are going to divide that by the initial mass. And then we're going to multiply the whole thing times 100% to give us a percentage. So, for example, if I wanted to do the pituitary comparison here, I would say, okay, for the pituitary for this comparison, I am going to take my final mass, which after the hormone is 10.1 milligrams, and I'm going to subtract the initial, which is 12.9. Then I am going to divide by 12.9, and then I'm going to multiply the whole thing times 100%. So if you punch that into your calculator, you should get negative 21.7%. The negative sign means this is a reduction, so you can see that that must be because we have reduced the mass from our initial to our final. If you got a positive number, that just means the thing has gained mass since the hormone was injected. So try not to get too hung up on the negative or the positive part of that. So basically, the reason why we're calculating this is because not every little change is going to be significant. And our threshold for determining what is significant is if you see a greater than 20% change, then it definitely is significant. So a 21.7 reduction in pituitary mass is absolutely significant. So we're going to say that that is a reduction of 21.7%. And then if we were to go ahead and do the rest of these, we would see that the thyroid dropped by 2, and since that is not 20%, we are going to act as if that is no change at all. The thymus dropped by 47.4%, so that is a definite significant change. The adrenal glands increased by 150%. Wow, right? So that is definitely significant. The seminal vesicles dropped by 2%. So again, that is not significant because it's not greater than 20, so we're going to pretend like that is no change at all. The prostate increased by 1.2%. That is not greater than 20, so we're going to pretend as if that is no change. The testes dropped by 6.25%. Again, that is not greater than 20, so we are going to pretend like that is no change at all. And then the body weight dropped by 33.3%. So that is definitely a significant change. So at this point, what are you going to do with this information? Well, definitely you want to just pay attention to the significant changes. So I recommend kind of recapping what you found out. So whatever hormone we injected into this intact rat, it caused the pituitary to shrink by 22%. It caused the thymus to shrink by 47%. It caused the adrenal glands to grow by 150%, and it caused the body weight to decrease by 33.3%. So that's the information that you're working with. So if we go back here to our list of hormones, we can see that the hormones that we have to choose from are ACTH, cortisol, luteinizing hormone, thyroid stimulating hormone, thyrotropin releasing hormone, and testosterone. So what you should be asking yourself is, which one of these hormones that if I injected it into a rat would cause these changes that we see right here? So for some of this, you may have to go back and read some of the background information that you find throughout your packet. So in particular, if you want a hint to get you started, look at the thymus right here. The thymus shrunk by almost 50%. Well, the thymus is not an endocrine tissue. It is actually an immune tissue. So somewhere in here, there is information about a hormone that has immunosuppressive function. So you may want to find that page for a little hint on what kind of hormone would cause that to happen. So the other piece of advice I have for you is towards the end of your packet, there are going to be some helpful diagrams to help you understand how the negative feedback works and how the regulation between the hypothalamus and the anterior pituitary works. So I've drawn all over this one because I've spent several years doing this lab with my students and just naturally tend to draw all over it. So you'll definitely want to pay attention to those negative feedback loops and ask yourself, okay, if I say injected ACTH, what would that do to the levels of cortisol? What would it do to the levels of CRH? And again, the reason why you want to pay attention to which tissues are shrinking and which ones are growing is because the idea is that if a tissue is overstimulated, then it's going to tend to grow. So for example, the adrenals grew quite a bit, so that's evidence that the adrenals are being overstimulated with something. So you may want to ask yourself, well, which hormone would cause the adrenals to grow in size? And then if the pituitary is shrinking, well, what lack of hormone would cause the pituitary to shrink? What does the pituitary get stimulated with in this particular pathway, and is there a reason why that hormone would be especially low if I injected a particular hormone? And then the last thing to look at here is the body weight. So if you are having a wholesale reduction in body mass, that tells you that your hormone is doing something to break fats and muscles down. So you might want to again go back and read about some of the effects of these hormones. For example, cortisol and thyroid hormone are going to have catabolic properties in which they break down stored up sugars, break down stored up fats. So if you have a lot of thyroid hormone or a lot of cortisol, you might expect to see a reduction in body mass. On the other hand, testosterone has an overall effect of making you gain muscle mass. So if you see a reduction in body mass, you know for sure you didn't inject testosterone, right? Okay, so I think that's going to do it for this little video. I certainly hope that you found it helpful. I hope it gives you a good head start, but if you still are having difficulties with this, definitely let me know. Oh, and the other thing is definitely when you're doing this lab and you think you have all 6 hormones identified, before you turn it in, send me a quick email and just say that these are what I think the 6 hormones are, and I can just quickly check your work and let you know if you're on the right track or not. I don't want you to spend a whole lot of time and then submit something that maybe has a bunch of wrong answers. So definitely run it by me a few times until you feel like you've got everything completely right. Okay, so I've taken enough of your time, so I will go ahead and sign off and see you next time.